Ok. Parece que tá indo, né? Hello, hello. Ok. Vamos ver lá no YouTube se dá. Parece. Não tem nada. Folks, if you are there and you are hear me, can you please say in the chat? I'm not sure that I'm going to be able to follow the chat. Can you say in the chat if you are hear me, or write something in the chat so that I know that the conversation is there? Join the conversation, interact with the creator, open the panel. Folks, if you are there and you are hear me, can you please say in the chat? I'm not sure that I'm going to be able to follow the chat. Can you say in the chat if you are hear me, or write something in the chat so that I know that the conversation is there? Join the conversation. See if anyone writes anything in the chat. Hi, folks. Good afternoon. I hope you are doing well. I'm sorry that we have a very technical issues. I wish to start a little bit earlier, but I have been trying since 9 o'clock in the morning to find a way that we can share not only the voice and the image, but also that we could possibly share something from the iPad that we can write here and share with you. So apologies for I still working the details here, and I'm going to stand up from time to time to look at the chat here to see if there is any questions. Okay, so we start very shortly. Stay tuned. All right, so let me try to share the iPad now. That was the major thing. Device, iPad on iPhone via keyboard. All right. Okay, that's doable. Voila. Stop sharing. All right, so let me shoot. Let software update required. iPad not now. Okay, got folks. Getting started here, and like I said, we had some technical issue that I tried to solve with my IT colleague here in the department. That was not possible. But anyhow, finally we are here. And what I would like to do, this is the first office hour of the quarter, right? So we don't have much material to cover. But if you have questions, just type it in the chat. I'm not seeing the chat immediately, but I'm going to be checking. And if you don't have any questions or clarification that you want to do now, so you just let me know, and I will then share some of these problems. These are called warm-up problems, okay? So these are warm-up problems that they could be useful in terms of practice for the exams that are coming later, okay? So these are a problem from Garrett and Grisham. And it says here, I have the iPad here so that I can write on that, and probably you can see that nicely there. And the questions then ask here, E. coli are about 2 micrometers. Yesterday we talked in class about this micro, nano, and so forth, right? So that's 2 micrometers long and 0.8 micrometer in diameter, okay? So how many E. coli cells laid end to end would fit across the diameter of a pinhead? Assume a pinhead to be 0.5 millimeter. So this is a very simple thing. Actually, this is not a biochemist problem, right? But we needed to get the warmed up in terms of these units and the how to deal with those things, right? So basically, let me see if it is working properly. Basically, what it is saying is that this is there's 2 micrometers, the length of this E. coli cell, and we have here a 0.5 millimeter. 0.5 millimeter. This is not obviously in scale, right? 0.5 millimeters is much larger than 2 micrometers. But what we have here is that how many of these cells I can put one head in the tail, to make the cells to give 0.5 millimeter was the diameter of a pinhead. So basically, it's just to give you an idea how small these are, because a pinhead is something very small, 0.5 millimeters that you can see with the eyes, but much smaller than that we can't. So there are various ways to do that. One way we can say, okay, well, the number of cells multiplied by the size of the cell. Okay, the length of the cell is 210 to the power of -6 meter, correct? All right, so the number of cells multiplied by this, we want it to become 0.5 millimeters. So what I'm doing is that I'm writing everything in meter. So there's a common unit here, okay? So now I have the problem in front of me that became very simple. There are various ways of solving this problem, not saying that it's the only one. And also in our exams, we don't ask you to write only one single way. There are multiple ways of come to the same conclusion. So what I'll do here, n equal 0.5, 10 to the power of -3, divided by 2, 10 to the power of -6. We expect this number to be larger than 1, right? We expect this number to be a larger number, a number of cells that are going to get together. So calculator, very important to have a scientific calculator for the exams. 0.5, 10 to the power of -3, divided by 2, exponential, -6, and it gives us 250. 250. All right. So I'm talking and hoping that you are getting this thing there, but I'm going to check it after this part B that we solve here. All right. I'm going to check at the chat, because here in my iPhone, I don't see anyone talk in the chat at this point. And I can hear myself here, but I don't want to put the sound so that it doesn't get on the way. All right, so let's do part B. What is the volume of an E. coli cell? Assuming it's a cylinder, with the volume of a cylinder be given by V equals PR squared times H, okay? So this is the volume of a cylinder, but there are, this is the volume of a cylinder here is given. So you don't have to remember this thing from your days in high school, that the volume of a cylinder is such, but you already know that here from the problem, and even the problem gives pi, which you don't need because you have a calculator that's going to give you that number. But let's use exactly that number. So basically, we have a cylinder here, so something like cylinder, right? So the cylinder here, this is going to be the H, right, of the cylinder. And the diameter of this cylinder here, the diameter is going to be 0.8 micrometer. That's what we have there, right? 0.8 micrometer, right? And the H, we also know that the H equals 2 micrometer, right? This is going to be the H here, 2 micrometer, correct? We don't use the diameter when it is calculation. We use radius. So the volume is again pi r squared times H, right? So we don't use the diameter, you use the radius. So if the diameter is 0.8, the radius is going to be 0.4 micrometer. So this is not about you know the formula of a cylinder, volume of a cylinder, things like that. This is just for you to work with the units to make sure that you don't get in trouble with this milli, nano, and so forth. All right, so let's calculate the volume. Then the volume is going to be pi. Pi, let's use 3.14 since they gave it. And then we're going to have r squared. So r is going to be 0.4, 10 to the power of how much? -6, correct? -6, 10 to the power of -6. And this is multiplied by h, and h equals 2, 10 to the power of -6. Am I forgetting anything here? Yes, I am, because this is pi r squared, right? So I need to have this thing here squared, correct? Okay, so you can put this thing in a calculator and directly get the answer for that problem. You don't need to go into too much detail there, but let's start it then with 0.4 exponential minus 6. Instead of square, I'm going to do the same thing twice and multiply that by 2, 10 to the power of -6. You could solve that problem in a different way, doesn't matter, times 3.14. Oh, shoot, sorry, went too much. So that gave us 1, the volume here is 1.0, 10 to the power of -18, but this is in cubic meter, right? This is in cubic meter. Let's write that. Let's not skip any step here, especially that we are doing this thing via YouTube, and then it's difficult for interact directly. So let's do that like that, step by step. Let's say this is meter, cubic meter, right? 10 to -18 cubic meter. So you know that 1 cubic meter equals 1,000 liter, right? Because we are going to be talking about liters here all the time. So 1 cubic meter equal 10 to the power of 3 liters, right? Sometimes you write L with a capital L to emphasize that, but the unit is actually in lowercase. All right. So let's then do like the following. Let's say we found 1, 10 to the power of -18, but I don't want the cubic meter because I don't understand much what cubic meter means. It doesn't make much sense to me. I want things in liter. So I'm going to replace cubic meter by 10 to the power of 3 liters. Make sense? So that would give me the volume, then, oops, sorry, my goodness. Okay, so the volume would then be in here very crowded because I mess up the whole office if you're trying to do this thing. So that the volume would be 1 10 to the power of -15, correct? Liters. 10 to the power of -15 is femto. So this is going to be equal 1 femtoliter. I'll put capital L in that case to make it very clear, okay? 1 femtoliter. So let me look at the chat here to see if there is any question, because I cannot see on the phone, so I have to look at the other computer here. Give me 1 second to see. There are no questions in the chat. I don't know if the chat is disallowed. There was another glitch also in the Zoom that didn't want to pre set the live. Anyhow, I don't want to go into much detail. You don't need to know all the details. We are here. That's what is important. We're going to solve a couple of problems, and then you go home for dinner. If you are at home already, you have time to prepare for dinner. So let's go to the letter C. And in letter C, Gary and Christian are asking, what's the surface area of an E. coli cell? What's the surface to volume ratio of an E. coli cell? We already know the volume, right? We just calculate the volume. Now the question is about the surface to volume. We already calculate the volume. Then we know that. So that's there. We already know the volume, but let's calculate now the surface area. Today is the day. Okay. All right. So let's go back here and do that again, and again, and again. All right. So what we do with that? Now we want. Okay. Yeah. Okay, so we're going to be back to that problem there. For some reason, to disappear, I can restart here. And the whole thing is to write. That's the major point here, is to be able to write. And if this does not let me write, then that's no point, right? All right, so that's. Sorry, folks, for the technical issues here. Huh. Bear with me there. Be patient. This thing is happening. Every time that we wanted to overuse the technology, we had issues sometimes. But we'll be there at some point. Here we go. Never lose your patience. Not worth. So we already calculated the volume, and now we needed to calculate the surface area. All right, so how do you calculate the surface area? Again, we have a cylinder, right? A cylinder, something like this. If you have a cylinder, if I have a piece of paper that is sitting around here, maybe just one piece of paper would be helpful if I can get one. Maybe this one is too big, but anyhow. So if you have a cylinder, we have a cylinder, so it's something like this, right? So I needed to know this side, this dimension, to multiply by this dimension to get the area of a cylinder, right? So this circumference around the cylinder, this circumference is 2πr. Okay, so when we have a cylinder, the circumference here, the area of the cylinder, the area here is PR squared, the area of this part of the cylinder, the bottom and the top, not the area around. But the circumference here is 2PR, and if you multiply by the length, it's going to be 2PR times H, then it's going to give this whole area here, okay? Let's calculate this area first. Then we calculate the area of this side and the area of this side, okay? So basically, what we're going to be doing here is that we're going to say, okay, we have two areas here. One is A1, which is given by 2p pi r times h. You understand now, right? Or if you don't remember this formula, you might as well remember the formula. And another area is going to be the p squared. So that's the area of the cover of the cylinder on the bottom and the top, okay? And because we have two sides of that, the total area will be 2 pi r times h plus 2 times pi r squared, pi r squared. Why 2 times? Because then if you have a cylinder, we are going to have it on one side and the other side, the bottom and the top of the cylinder and the surface around. So that's why we have PR squared twice, all right? So let's plug in the numbers. What the numbers that we have, the area, I'm just going to AT, area total, is going to be 2 times 3.14 times R. We already know that's 0.4, 10 to the power of negative 6. This time is linear, it's not to the square, times 2 10 to the power of negative 6. Do you know what this 10 to the power of negative 6 is? From the part before, right? This is the length, okay? And that's not all. This is just the first part of the area. So that if you want, you can separate that to make it less prone to mistake. For example, you can say, okay, I'm going to work only with the area 1 first, get one response, get the other one, and then combine these things together, okay? So let's do that way. That's another way of doing things. So what we have here, 2 times 3.14 times 0.4 exponential negative 6 times 2 exponential negative 6. I got here 5.024, but I'm going to say 5.0. Not going to go all that down there. 10 to the power of negative 12. And what unit is this thing? What unit is here? We have area, and we put everything in meter. This was something in meter. This was also in meter. So meter times meter is meter square, which are unit of area. But with this, we calculate only the area of the surface. We didn't calculate the area of the bottom and the top of the cylinder. What we are going to do now. So the area 2 is going to be 2 pi, and we already decided that we're going to do the pi that they gave us, 3.14, and multiplied by the radius, which was 0.4, 10 to the power of negative 6, the same one on the top there, but here it is squared, right? So here's the squared. All right, so let's find out how much that 0.4 exponential negative 6 and multiplied by 3.14 and multiplied by 2. I got the, yeah, I got the total area. I got 1 at 0.048, but I'm going to just say 1.0. 1.0. It's a little bit messy here. Why not a little bit better than that? Okay, 1.0, 10 to the power of negative 12, which is convenient because they are all in the same 10 to the power of negative 12. So now we have 5 from the other one, and here, so the area total is going to be A1 plus A2, which is going to be 5.010 to the power of negative 12 square meter. I'm not going to write that. Time plus 1, 0.0 actually, 10 to the power of negative 12. So this is going to be area total, and it's going to be 6.010 to the power of negative 12 squared meter. Make sense? Squared meter, okay? Anyone with questions here? No. All right, so we had the volume before, and we have the area here. So the next question is, what's the surface to volume ratio? Surface to volume. So we are talking about area total divided by the volume. That's the whole surface divided by the volume, okay? So the whole surface is 610 to the power of negative 12. This is in square meter. And the volume from before, I don't remember that, but I think it was 10 to minus 18, something like that. Let me see. Yeah, it was 10 to minus 18 cubic meter. 1 10 to minus 18 cubic meter. So if you put the units here, it's going to be very clear that this ratio is going to be meters to minus 1, right? Whatever this ratio is going to be here, this ratio is going to be 6. 18 becomes positive minus 12, 6. So that's going to say 6 to the 10 to the power 6 meter minus 1. All right? If you guys do not have any questions, I can do one more, but let me see here if there are questions here or anything. All right, so this is oh, well. All right, so we have lots of questions actually, but my iPhone was not showing them. Perhaps I could have, if there was not so many technical problems, I could have that in the other way before. Okay, so let's see here. Started, all right, so would you be able to show units for the final conversion? I'm not sure what the question because I didn't get on real time. Maybe I missed the point, but maybe we are talking about a dimensional analysis by plugging in with the dimensional analysis. That's also possible. That's also possible to do this the problem that way. Do you have no, I didn't have a warm-up problem. I just created this thing. I copied from the textbook. I didn't give anything in advance. All right, so anything else? Okay, so let's see. I think you need to specify the units you want in the end. The units that we need in the end is the units of the problem, okay? It would be specified. If I have liter, I probably would ask how many liters of this would arrive at the end, okay? So that would be one way. Would they be given formulas on the meter term? Depending on the formula, not this kind of formula. I'm not going to be asking questions about what's the volume of a cylinder or anything like that. So we would not need those kind of forms of geometry, okay? And if you need to memorize this for the exam, I'm not sure what this means, but I would almost certainly say the question, would you memorize this for the exam? I'm not exactly sure what it means, this, but I would say that none of this thing here is going to be to memorize for the exam. If there is an exam that requires memorization more, would be the midterm one and the final exam. Midterm one is a lot of calculation. We don't need to memorize anything, okay? So if you have the question, apologize if I didn't see the chat on real time, and because of all the technical issues that I have, I didn't have time to prepare to have a complete setup here, which I would have normally with the other computer, and we'll be look at that more easily. Anyhow, so the answer for that question is that no, we don't have to worry so much about that. So let me see if I can set up another one here and be. All right, so let's see if there are no other questions. Let's do another one. Let's do another problem here. Oh, glucose. Glucose is a good one. Glucose is always an exciting idea. Glucose is a major energy yielding nutrient. It's present in bacterial cell at a concentration of about 1 millimolar. Yesterday we were talking class very briefly about concentration in the blood, right, in human blood. What's the concentration of glucose expressed in milligram per milliliter, and how many glucose molecules are contained in a typical E. coli cell? Recall the Avogadro number is 6.023, 10 to the power of 23. I'm not going to ask you to memorize many formulas of chemical compounds, but is there one that I always expect that everyone knows in class is glucose? Okay, so that's the C6H12O6. Not that I'm going to, what's the formula of this pyruvic acid, for example? I'm not going to expect that for this class, you're going to need more of that for 103, but if there's one that we are going to, if there's a question in the exam and the formula is not there, is not unusual for this particular compound. Other compounds, probably there will be a formula there. And the question is that the concentration is 1 millimolar. This is a very typical, very simple question that we need to utilize this thing back and forth. Concentration can be given in milligram per milliliter or gram per liter and so forth. And the concentration can be given also in molarity, right? So molarity is defined by the number of moles by the volume in liters, okay? The number of moles divided by the volume in liter. And then the number of moles is the mass in grams divided by the molecular weight. That's how we get the number of moles, right? So if I plug in the number of moles here, the number of moles being the mass in grams divided by the molecular weight, all I did in here, I'm using this as a replacement for N, okay, for the number of moles, okay? And so I still have the volume in liter here, which comes from the formula, all right? So basically, this problem tells you, well, when we have a concentration grams per liter, and the grams per liter is going to be the same thing as milligram per milliliter, because both of them are in milli and the milli, right? So this formula here tells you that in general, the molarity equals a concentration, which concentration is given gram per liter, divided by the molecular weight. So that's an association there that we always have that available to us when we need it to go back and forth. So if I need to know the concentration here, I multiply the molarity times the molecular weight. All right, the molarity times the molecular weight. So the molarity was given as 1/10 to the power of -3, but I don't have the molecular weight. All right, so you have to calculate the molecular weight of glucose or any other compounds that appear in the problem. Like I said, I'm not going to expect you to know what's the molecular form of Ozempic. No, I'm not going to expect you to know that. But if I give the molecular form of Ozempic, I expect that you know how to calculate the molecular weight, because in our problems, we have in the first page of the exam a data table with all the information that we could use for all the problems. Sometimes it's more than we need. So you just look there and pick up what you want and carry to your problem. So atomic number, atomic mass, and so forth is going to be given there if you need. Here we need for hydrogen, carbon, and oxygen, right? We know that the hydrogen is 1, carbon is 12, and oxygen is 16. If you put this thing together, 6 times 16 from the oxygen, 12 from the hydrogen, and 12 times 6, 72 for the carbon, you come out with the molecular weight of this species here is going to be 180, 180. You can say grams per mole, uh, grams per mole for the molecular weight here, right? So let's plug in here, 108. I know that this thing is very simple here because 100 divided by 1, 2, 3, 0.8, 0.1. I pick up the calculator, but I don't need the calculator for this. Milligram per milliliter. Why did I milligram per milliliter? Did I confuse you? Hopefully not. But if you want to go step by step and don't want to get any confusion, you just put here gram per liter, right? Which is the same thing as 0.18 milligrams per milliliter, correct? So that way there is no confusion because you did all the steps that were there. How many glucose molecules are contained in a typical E. coli cell? That will be the part B of this problem. Part A, we solved it here. We found the concentration in milligram per milliliter. The solution is there. Problem solved. Now, the question is how many glucose molecules are contained? So what we need to know for that? We need to know the number of molecules. We need to know the volume of the cell, right? Because we have the molarity equals the number of moles divided by the volume in liter, correct? So if I know the volume and I know I can calculate the number of molecules. So for example, from here, I can say that the volume in liter, I can say that the volume in liter is going to be the number, or the number of moles, better say. That's what I want here, the number of moles. The number of moles is going to be equal the molarity times the volume in liter, correct? Agree? So now we have that, then we can go there and plug in. But what's the volume of this thing in liter? We calculated before. It was 10 to the power of negative 15, I think, liters. Yeah, this one here. 10 to the power of negative 15 liters, right? So I have the molarity that's equals 1 millimolar, 1/10 to the power of negative 3, multiplied by the volume in liter, which is 1/10 to the power negative 15. So all in all, this is going to be 1/10 to the power of negative 18. What unit here? We are looking for the number of moles. So the unit here is going to be mole. Some people sometimes write moles, but the unit doesn't change in plural. The symbol of the unit, mole, is mole, M-O-L, not moles. We're not writing as a word here. We're writing a unit. All right. For example, in the common parlance, people say, "Oh, I bought 5 kilograms of this and that." But in science, we put 5 kg and we don't put kgs, right? Okay, so that's moles, not moles. But this does not answer the question because how many glucose molecules, not moles, molecules. All right. So you have to multiply these numbers by the avocado number to get the number of molecules. The number of molecules, that's a different thing. The number of molecules is going to be equal to the number of moles times the avocado number. The number of moles is 1/10 to the power of negative 18. And the avocado number is 6.023, 10 to the power of 23. So this is going to be nearly, because let's not talk about 0.603, but let's say 6, 10 to the power 23 minus 18 is given 5, right? 10 to the power 5 molecules. Now it's not moles anymore. Molecules of glucose. Let me see if there are any questions or something that we need to address. All right. So where did the 1/10 to the power 15 comes from again? Where's the 1/10 to the power 15 comes from? 1/10 to the power 15. Let me see where that is so that I can get an answer for that. When 1/10 to the power 15, maybe from the previous problem. 1/10 to the power 15. Where's that number? That's the problem sometimes with Alive if I didn't have that thing in here, but next time I'll be more real time. And another question that came out is that where we find the Pratt's problem. It's still too early for that. I told you week 1 is not the week to get to worry about solving problems yet. This is just a practice here because we have an off hour, then we can do that. Week 2 is that when the problem starts. So when we find the practice problem, that's when you find it. Because starting next week, I'm going to be assigning problems to you, one after the other. And it's going to be an avalanche of problems that are coming. So there are going to be lots of problems. And then when it comes close to the exam, if necessary, I can give you also a practice test or example of exam from previous years or something like that, so that if it helps. But first, let's concentrate on solve the problems that are assigned, because sometimes some of these problems are very similar in the exam. Okay. So I hope that would help a little bit. And it's already 6 o'clock already. So I'm going to stop here, and I look forward to see you all in class tomorrow. This probably would stay there. So other students that were not able to attend live would be able to find in the biochemistry channel the same solution for this problem. So very simple one today, because we are just trying to patch something here, no concept that are very essential for the first midterm exam, but a few hints here and there, and what you can do in terms of this warm-up. I look forward to see you tomorrow. Bye-bye now.